Good morning, everyone. It's Coach Fred here, and today I'm going to be going over graphing quadratic inequalities in two variables. So, we did go over this if you're in my class, and if you're not, you're just watching. These are basically what we discussed and talked about. First, you want to graph the parabola. And so you want to use some of the skills that you have for graphing parabolas, and you really should identify what form it's in. Make sure that if it's greater than or less than, you use a dash line, but if it's greater than or equal to or less than or equal to, you use a solid line. You then pick a test point not on that boundary line. It cannot be on the boundary line. So I know we tend to want to use 0, 0 as a test point, but if 0, 0 is on the line, you can't use it. So test it. If it's a solution, shade the part of the plane that contains the point. If it's not a solution, shade the part of the plane that does not contain the point. Okay, sounds easy enough, but we got to recall all the skills we have for graphing parabolas. Okay, so I'm looking at this. Now, when we graph it, the inequality symbol doesn't matter. So we really want to consider it without the inequality symbol. So I'm going to look at this as y equals to x minus 5, x minus 1. Now, since we're starting to review for exams, it's really important for you to say to yourself, okay, what form is this? So this is intercept form. And remember, Coach Fred doesn't really like to call it that because there's different intercepts. I like to call it X-Intercept form because these represent the X-Intercepts. All right, so my X-Intercepts are 5, 0, 1, 0. I recognize that the graph opens up and has a vertical stretch of 2. But, I don't have to be really, really crazy about this. So we're going to plot those points, 5, 0, 1, 0. So here's 1, 0, 2, 3, 4, 5, 0. Okay, now I got to find the vertex. So remember, the vertex is directly in the middle. It's going to be the average of the x-intercepts. Now on this one, we could easily just count and see that the x-coordinate of the vertex is going to be 3, but you could also just do 5 plus 1 divided by 2, okay? So that's going to be 3. Now that's the x-coordinate of the vertex. To find the y-coordinate of the vertex, we're going to plug in 3. So 2 times negative 2 times 2. So that's going to give me negative 8. All right, let's plot that. So 3, 1, 2, 3, 4, 5, 6, 7, just at the edge of my graph here, of my page. All right, now you could find your y-intercept as well by setting the equation, by setting x equal to 0 and solving for y. So let's do that. So y-intercept. So that would be 2 times negative 5 times negative 1, which is going to give me 10. So 0, 10 is my y-intercept. And that's like way up. 1, 2, 3, 4, 5, 6, 7, 8, 10. Yeah, that's at the top of my graph. All right, now I can use my axis of symmetry straight down the bottom to reflect that point. So that means I'm going to have another point at 6, 10. All right, and then I'm going to do my best here, but I know it's not going to be a pretty parabola. I'm going to draw my parabola, rounding at the bottom, coming up. Okay, so now we have our parabola, and so now we deal with the inequality. So I'm just going to see where I'm going to be shading this inequality. So I'm going to pick a test point. I actually decided to pick 3, 0 just because it was right there and it looked pretty easy. So I'm going to do y's, I'll do it down here. Y is less than 2. 3 minus 5 is negative 2. 0 is less than 2. Negative 2. And then 3 minus 1 is 2. So 0 is less than or equal to negative 8. So that looks like that's not a true statement, right? Negative 8 is not greater than 0. So that means that we would be shading in the opposite side of the graph. So all the way under here, over here. Notice I'm using a highlighter because it's just easy. So the solution to this inequality looks like that. Okay, so now you have to be really careful because you could be faced with graphs that are in standard form. So just as a reminder, standard form, to find your vertex, x equals negative b over 2a. Right? Again, we're looking at it with like it's an equal sign. So you have to be careful because sometimes your X-intercepts aren't going to be whole numbers. So just remember, you always have that quadratic formula as well. So I calculated the vertex by doing that. I got negative 16 over negative 4, which was 4, and I plugged that in, and I got a y value of 1. So my vertex was 4, 1. Okay, so 1, 2, 3, 4, 1. Now I saw that negative 2 made this graph, so it's pointing downward. Okay, and then I just needed to find the X-intercept. The Y-intercept, remember, is that constant, so that's kind of off my graph, so I'm just not going to worry about it. I used the quadratic formula because this was not a factorable equation. Okay, so you use the quadratic formula to find your X-intercepts. I already did that for us, and they were approximately, because they were irrational, 3.29 and 4.71. So I'm going to graph those. So 3.29 was right about here. 4.71 was right about here. And so I have a parabola looking like that. I'm going to go off the graph here. All right, so now I'm gonna use a test point. I'm gonna actually use 0, 0 because I think it's nice and easy here. So 0 is less than or equal to, or greater than or equal to negative 31. Which is a true statement. 0 is greater than or equal to negative 31. So we would be shading on this side of the parabola. Okay, so that's really a basics how you do inequalities. And it's very similar to what we did with systems of inequalities and linear inequalities. Okay, but how do we do it algebraically? That's the important part, right? Like we sometimes have to do these algebraically. So here's an example. I'm going to do, from your worksheet, this one, x squared minus 36 is less than or equal to 18. Okay, algebraically, I want you to think about what this would be as an equation. So as an equation, you bring the 18 over, right? So this is what we're looking at. So graphically, what we're saying is we're looking for where the quadratic, because this is the quadratic, is less than or equal to 0. Okay, so I want to visualize this quadratic just so you can see it. Remember, I love using the rule of 4, thinking about it as a graph. So if I graph this, I actually can see that if I factor it, it's going to be x minus 6 and x plus 3. Okay, so that means that I have x-intercepts at 6 and 3, negative 3. And for now, I'm just going to do a quick sketch of it, okay, like that. I know it's opening up, so it's something like that. I don't know the vertex. I'm not asking you to do it graphically. But what I do know is that the quadratic, if I call the quadratic this red line, the quadratic is less than 0 from here to here, right? This is where it's less than 0. So we call these 2 points where it hits 0, we call them critical points. So if I want to do this algebraically, first I'm going to factor the equation to find the critical points. Okay, I call them the CPs. Okay, so then I write those critical points, negative 3 and 6, on a number line. Okay, again, this is algebraically. Then I test points to the left, middle, and right of the critical points. Now, it is going to be equal to 0 at those points. So we know it's going to exist there. All right, so if I pick the point negative 4, okay, so I have to plug it into the inequality. So I'm going to use it in factored form. So negative 4 minus 6, negative 4 plus 3, is that less than 0? Okay, so let's see. Negative 4 minus 6 is negative 10. Negative 4 plus 3 is negative 1. I can actually see that that's going to give me a positive 10, which is not less than 0. So this is not less than 0 here. So I'm going to put a negative. You could put an X, but this is called a sign chart. So it is not true there. So that's why I put a negative, so not true. All right, we pick in the middle. I'm going to pick 0 because it's a nice easy one. So 0 minus 6, 0 plus 3, is that less than or equal to 0? So negative 6 times positive 3 gives me a negative number. You don't even really have to finish it. I know it's a true statement, so I'm going to put a plus. Okay? All right, and then I do the other side. So I'm going to do 7 minus 6, 7 plus 3. I can already see this, right? Like I have a positive 10 and a positive 1. So that is not less than or equal to 0, right? 10 is not less than or equal to 0, so it does not work here. So this sign chart now tells me wherever there's a plus and or a solid point is the interval in which this is a true inequality. So we would write it with interval notation, hard bracket, -3, comma 6, hard bracket, and that would be the solution to the inequality. Now, I really want you to think about that graphically, right? See, from here to here, the graph is below 0, okay? All right, hopefully that was a helpful video. I want you to try the rest of the problems on your worksheet and have a great day.